Awesome. This room is quite empty. Matas, I think you've avoided I would say, start of the day. But usually that happens sometimes. But nonetheless, my name is Tebogo Tlhopane, the architect and founder of Zaga. Our basis, basically, for ML, machine learning, is to be able to apply machine learning in an environment where data sets are really hard to come by. And I'm talking about an informal environment, an informal space where we are operating. And I wouldn't call it a wallet, I would call it an infrastructure. I think the challenge, if you start comparing whether you're offering a wallet services or an infrastructure, is when you had to understand what is the difference between the two. But I think what I'm here to talk about is exactly that. To say what are we doing and what are we trying to achieve, and why are we using AI really to get to this? So if you look at what we understand about machine learning and what we're trying to achieve on that basis, it's very, very important that we align with the conditions. I've spent the past 2 days listening to various different speakers and opportunity to interview Khalil, the president of AMLD. And I think the basic thing and most important thing for us was to be able to really put out there the capability of what it is that we are able to do and why it's important. And as I highlighted, that we need a Africa-centric AI, Africa-centric data, because we don't have that. And when we're looking at an informal environment, these are situations where it relatively does not exist. So if you look at why Zaga is here, I think the most important thing that I'd like to highlight on that basis is that looks like I'm going in and out all the time. No. So on that basis, can you hear me? Okay. So on that basis, what we as Zaga has done, or at least within the environment where we are, is that you're looking at if you look at townships and informal settings, an area where a lot of the banks are able to come in, a lot of the banks are able to provide these services. We call it.
It's way better.
Thanks. Okay, so it looks like when I'm standing here, it's better. I shouldn't be moving around, I suppose. So, as I was talking about, why are we here, and how do we see AMLD playing a part and a role in a space like this? As Africans, and I'm sure you guys are familiar with the challenges that we face as a continent, is that we have a lot of underbanked, is the economic term that's used to describe people that have no access to formal banking. So I call it poor banking, basically, because when you say underbanked, it sounds so very posh. But the reality is that we don't have structured banking within these environments, rural areas. And as you are aware, banks are retreating. I don't know how it is in other parts of Africa, but in South Africa, we see that the banks are retreating, leaving a huge gap between the communities that have no access to banking. But the primary thing that's most important for me being here is that to showcase to you how we are using machine learning in order to solve some of those challenges. in an environment where there isn't really a classification. Yesterday we had an opportunity to talk to listen to a lot of different speakers that were talking about genes that are being evaluated using machine learning, and by Dr. Tariq. And I had a pleasure, and my colleague here, Mr. Mantasa, will also come and talk about how that's used within engineering space. But the reasoning behind all of that, oh, and then before that we had also Mr. Patel from the US who was talking about the technology looking at how do you measure oxygen in your body. And some of the key issues that were clear and highlighted was that you have the challenge where the situation where the data sets, or at least the classification that you are put in, it's far removed from the reality of where you are, because it's based on white people's data, pure and simple. And as you know, we are different as human beings across different, continent. So our goal is that we need to get proper data, analyze that data, and be able to provide the right kind of solution to that environment. And what do we mean by the right kind of solution to that environment? If you look at the core problems that we have, that I've highlighted, the poorly banked scenario within these rural and township areas, and this stretches the entire continent. And we do have wallets that are out there, M-Pesa, it's one of the most common ones out of Kenya, MTN, we've got MTN Momo as well. But if you study and look at what is the throughput of these wallets, it's quite high, meaning they don't solve the cashless situation. Money comes into that wallet, and it goes out as immediately as it came in. So literally, you cannot measure anything in that environment, because you cannot really say, did we actually go decaching, or we just really creating a throughput? And it's the most expensive throughput. I don't know if you guys are aware of the charges that MTN, Momo, and PESA are charging. So all these things are quite critical for us to try and solve. So by looking at how do we solve these challenges that are highlighted on the screen without having to list them one by one, is that apart from everything else, if you go to the bank right now and say, I want credit, you never had a bank account before, there's nothing that they can literally check on you and say, Mr. John or Mr. Mtembu, we are unable to assist you purely because we have nothing, we have no knowledge, and because they have no idea of what goes on the ground. Our approach was a little bit different. We went after where the actual huge cash is spent. Where is that? The fresh produce markets. South Africa, fortunately, has one of the most impressive structure when it comes to the fresh produce distribution in this country. I don't know if you know that, but the heartland, the impact that it's doing within this environment is unbelievable. Where we've created an infrastructure that is actually taking fresh produce from the farmers directly in the hands of the consumer using these fresh produce markets. There's about 23 of them nationwide, Joburg being the biggest one. Joburg transact about 10 billion rand a year. The total transactions that you get out of the fresh produce market, it's about between 24 and 25 billion rand. Out of that, 10 billion to 11 billion is cash. And it's not only catering for the township, but it's also catering for our immediate neighbors, Mozambique, Zimbabwe, truckloads coming through, cash money, buying, going home, distribute. Now for us, it represented an opportunity to say, we can plug into that space, help it to go cashless, but we get one thing very, very clear in that space, is that we are not an MTN Momo. Money doesn't go in, money doesn't go out in that quick sense. We are trying to structure in such a way that we create a primary history, a history that can be followed, a history that can then be converted using ML to be able to give you, extend to you other benefits that normally corporate usually enjoy within a banking environment. But how do you do that without data sets? That's where the challenge is at. And this is where the power of how we came about to do what we are doing. by solving the challenges within that space of not having enough information to make the decision that you need as a bank, as a creditor, to say, I will give credit to Mr. Mtembu, I will give credit to Ms. Nozola. So whatever the case may be, this is where, in our sense, we believe that we are hitting that mark and we are solving those issues within that space. If you understand how, in most instances, a transaction takes place, if you look at our infrastructure in terms of what we've managed to achieve and what we've done, we literally it's an overlay of what exists within the technology itself. You have a technology of a wallet, but we see ourselves as an infrastructure, not as a wallet, because you're creating an infrastructure for people to participate meaningfully in the economy. And you want to make sure that that participation, meaningful participation, is be able to be tracked, behavior is able to be checked, we can be able to see those movement and anomalies. We are able to make those decisions based on the data that's coming in an environment where data wasn't really there. What do you do with this data is the most powerful thing, because then you are able to then give people dignity. Services that is tailor-made to them, not just a blanket. We're not coming in there and doing a classification scenario to say, well, you are black, you're in Soweto, therefore you don't have money. And that's pretty much the case. It doesn't necessarily mean there's no money in the townships. If I can tell you how much cash is in there, you'll fall off. There's over 500 trillion in the township. 500 trillion. 500 trillion. It's crazy. And it's all cash. And our goal is to try to take that out in the environment so that we can then be able to really give these individuals an opportunity, right? So when you look at our architecture, we are looking at signals that are coming in, and we structure those signals, and then we make an intelligence decision on how do we then work with this information. What do we do? Who gets what? What is your behavior when when you receive income and you put it in your wallet? What is then your behavior? This is what we're watching. And we constantly watch this, and we constantly change it based on what you're doing, so that we can then be able to create data sets that make sense. When I go to the biggest banks or creditors and I say, well, we've got over 250,000 people, for argument's sake, that are performing in this way and the other. We've got data that shows that these individuals are earning between 30 and 40,000 rand a month, and we can show you exactly how and where they're spending that money. And the money is coming in, and because we've created a lot of interesting points that are connecting together, you have that interoperability within that space that allows you to be able to provide services to these people, and they can, using other opportunities, be able to buy life insurance, be able to buy short-term insurances for various different things, be able to get a reward program that can assist in making sure that they stay. Because you don't want that high, fast throughput of money coming in and money going out. It will defeat the purpose. And that's the biggest challenge of any wallet, is that if you can solve that, then you've solved the issue of poor banking in the country. Now, the way we're using the machine learning in our case is that we're looking at patterns. Patterns, and these patterns, they differ from one cluster of township to another cluster, and they differ from one township to another. You've got Soweto, you've got Gooks, you've got Langa, you've got all various different townships. And every township, there's a different way of behavior. And it's key for us to understand that pattern. After we understand the pattern, we then cluster it accordingly based on that behavior. It's okay, behavior one, these are the guys that are keeping the money in the wallet. We see how that is working. Behavior two, these are the guys that are coming in. It's a high throughput environment. Behavior three, well, these are undecided people. And then you can then be able to then determine what place and which cluster get to be used, by the way, to be able to motivate other clusters to behave the same way by providing rewards and all sorts of things to that cluster, right? And you are able to detect any anomaly. For example, all of a sudden people are now cashing out. That's an anomaly. Why are they cashing out? It's very important to understand all those things, right? And with that, we can then be able to isolate these different events that are taking place, be able to identify. I mean, you guys were here when we had that issue in Durban, and it went national, where people were looting. You remember that? Right? Now, during those kind of times, you see a different behavior in terms of how people behave with monies that are sitting in their wallets. And that's the kind of anomalies that we always look at, and look at what behavior is then is taking place. But this is a gold mine, because you get to be able to use something like machine learning that will immediately make things much more faster. Dr. Tariq yesterday mentioned the fact that their capability to read genes and be able to come up with all the information that they've got, it took years for the medicine fraternity to do it, but it took them hours. That's the power of processing you have, that you are piggybacking on. And you can imagine with that much raw data what you can do in that space. I think I've covered this in my speech while I was talking, so we're not going to dive into that particular. But I think what we want to talk about is, where are these amazing stuff deployed? Now, I mentioned the fresh produce market as a benchmark. Now, why is that? Is that 10 billion rand gets to be spent there in cash. You're converting the hawkers, the vendors that are coming into the fresh produce market to be able to use the wallet. You are incentivizing them to keep the money in the wallet so that they can then also motivate whomever that they're selling to actually adopt the wallet themselves, so that you then create that trading environment. Now, who are we talking about? Informal sectors. If you look at the amount of spaza shops in the country, spaza shops are pretty much small, little mini supermarkets. And they are everywhere in the township. There's hundreds of thousands of them, right? Now, you could have asked the question, why didn't we not start there? Because that's not necessarily the place to start. You want to start where the money gets to be spent. From there, the produce are then transferred into that space. So when I come to you and I'm your wholesaler, and I just went to the market and I just wanted to buy my fresh produce, and I come to your spaza, the first thing I'm going to tell you is that, listen, if you want to pay me, use this wallet, because there's an incentive for you to do so. Similarly with the spaza, people that are coming to the spaza to come and purchase whatever they need to purchase, same thing you do as a spaza owner. Listen, if you want to save money, here we go, get yourself a wallet. This is the reason why we started there, because then you're creating that whole use case. MTN Momo, everybody grabs it, but what is the use case? You know what I mean? This is where the situation where the high throughput is there. You get money comes in, money comes out. Money comes in, money goes out. Right? It makes no sense. So this is very important for us to be placed in that space. The next level of it will be to look at how do you work with municipalities for things like behavioral change within the community themselves. Now, as I drive, wherever I drive, you see somebody open up a window and throw a bottle or a can or whatever outside the window, and then we complain about how dirty it is. And these are the kind of behavior change that we're going to go after, because we're going to incentivize you to be able to behave in a different way. And every time you see that happens, you go and grab it, you put it in a thing, take a snapshot to say, I've done that. And that's the behavior that we want to change. That's where we're going to go in now. To say we want to now plug into municipalities to say, we will help you clean the cities. But people will actually do it because they are incentivized, right? I'm guessing you're standing up because time is tight. All right, so quick one. I'll skip that because that's pretty much what I've covered already. So in a nutshell, we are here because we want to collaborate with researchers, practitioners. I had a great pleasure talking to Mr. Mantasa as well, looking at what they're doing. And being here, I'm here to say, let's collaborate, let's work together. Let us share what we've got. Let us see how we can effectively make this a solution for the continent. Thank you, guys.
Thank you very much, Dr.
Thank you.
Really valuable. So, we have some questions from the audience.
My question is, who is your customer? Who gets to pay you by for your services?
It's a very good question. So we went with a basic principle, is that for you using your wallet should be relatively free. However, you can also at the same time not just be a wallet user from a point of view of just using the wallet for you as a place where you put your money, but you can literally become also a merchant within the same space. So when you become a merchant, say you buy this, right? It's free. You sell it, we charge you money for that. So that's the difference. So our customer are the merchants themselves, not the wallet holders and wallet users, basically.
One question about I want to know in which stage are you right now? Do you already have a product that is ready? Do you have customers? Do you have investors? Maybe? And what are the plans in maybe 2026? Let's say even for the next 5 years.
So we're doing a POC with Joburg, which we should be starting, I would imagine, end of Feb. And we're doing a POC as well with Buffalo City, which is in Eastern Cape. Now, these are two different environments, and we did that deliberately because you're looking at your Eastern Cape rural, right, income down. Then you're looking at your Joburg. As I said, Joburg is literally contributing almost half of that yearly budget or yearly spend. And we're also looking at that behavior from the township and stuff like that. So this year it's going to be, at least for the first 6 months, where we're actually going to be doing a lot of POCs to be able to show how this is going. The technology is already in place. Obviously, we are tweaking it all the time to make sure that it's perfected to what we want. From a fundraising point of view, we haven't even started fundraising because what was important for us is that if we can come and say, here's the POC, here we can show you that our throughput is actually not high but less, and the percentage that you have of people that are keeping money in there, it's much more higher. And that's the goal because you want that the money stays. Use the little bit you have, money stays in there so that you use that as de facto your bank account, if you think about it, where you get incentives. So, but I need to come to funders with that perspective as opposed to saying, well, we're still not sure. So that's the goal with that. Mr. Matasa? Thank you.
Sorry from my side, I want to usually dive into the technical side. So when you talk about the signal capture, to deal with the scarce settings, concretely speaking, which models are you using?
So we have the pleasure of, I'm a user of ChatGPT, and I think the cool thing is that they all have these APIs. Anthropic has, and we kind of like, and we use them from a background point of view. So our data still stays, but we tap into the intelligence of the AI, but our data still sits there. So we don't share our data with any of the AI guys that are out there. But what we then do is that we're using our APIs to be able to tap into it. So we're using ChatGPT, Anthropic as well. And I think there's a second one that they're busy testing because of the mathematical capability. I mean, the DeepSeek is actually quite impressive when it comes to that, mathematical computation. And I think that's where we lean on as well on that.
Maybe one
Mm.
So maybe you have to target some explicit machine learning techniques like regularization, like feature engineering. There's a lot maybe to do in that side.
I would definitely take you up on that offer. As I said, I think one of the reasons we are here, most of all, is collaboration. And I think in this setting like this is where you get really amazing advice in terms of how do you need to move and how do you need to navigate and what are the best MLs out there that we could use based on experiences like you have. So we are more than happy to. That's also. That's also, Mr. Matassa. Thank you so much. Any questions? There's one last one.
I wanted to ask, what does your incentive system look like for the standard user versus the merchant?
So we've got different rewards programs that we've implemented and always are improving. For example, you've got, I don't know if you have a car, all this time when you're driving, you get point systems. I mean, you get like 0.1%. I always think it's a waste of time, right? But our incentives are based, and these are the same incentives that we are plugging into behavioral change of communities when it comes to things like, when you go around and you see people are throwing things, what do, right? So we plug in the same behavioral incentives in the same space where we say we reward you. So those rewards will come in a sense of airtime, things that are tangible, things that you can use. Things like point system that will help you with your short-term insurance. As you know, there's a lot of offerings in that space, but are they tailor-made to us? I don't know. So those are the kind of things that we always look at. How do we then incentivize and get people excited and galvanized to be able to keep their money there? And of course, when it comes to the level of interest that you get through when the money is sitting in there, there's an element of portion that goes to the wallet holder because we want you to know when your money sits there, not only you get all these things, but you also get a recurring interest on that cash.
Thank you very much.
Thank you.
Wish you all the success for your next steps.
Thank you, sir. Thank you. Thank you, guys.
Okay. So please now welcome Praise Amonier, founder of Deep Africa. He will talk about how we can apply ML in credit scoring in finance for Africa. So a round of applause.
So where should I speak? I should speak to this?
Yeah.
Oh, I wanted to be moving around, huh?
But there was a problem with that.
There was a problem with that.
The room is not good, so if it's too loudly, we can.
Okay. Okay. All right. This is not so comfortable, I prefer a microphone or something. Test. Yeah, I'll try my best. It's like my head is bigger than it. That has to be here. Okay. Is it good? All right. Hello, guys. How are you? Okay. First of all, I want to say thank you to the entire team of AMLD for giving me this opportunity to come share my work with everyone. I'm hopeful that at the end of this, we all would have had a good time learning and sharing together. So we don't have a large room, so with the number of people we have, I would like to make this session quite interactive. So I'll be doing the talking and you'll be doing the talk back. Is that okay? Hello? Hello? Yes, when I say hello, you say hi. You get that? Hello? Hi. Now you are an awesome audience. Okay, so let's get to it. So I would like to ask a question. Let's say, for instance, you have a friend who walks up to you and say, I need you to borrow me some money or give me a loan or something. What would be the first, let's say he's asking for half of your current account. What would be your first question to that friend? Anybody? Okay, nice question. Another one. He said, will I get my money back? Another one. So the question is, a friend walks up to you asking for half, 50% of your current account. What will be your first question to that friend? When are you going to pay me back? Another thing you might want to think is the last person okay, what am I getting? Okay, what will be my, my interest or something? Awesome. Now, another thing that many times comes to mind is you would want to know if that friend has borrowed from someone else who has paid. Do you understand? So maybe he borrowed from your other friend. You want to confirm, did he pay his last debts, right? It's a good question, because with that you can be able to know if the person will be able to pay you back or not. And that is exactly what I'm trying to present to you today. It is called credit scoring. Unfortunately, in Africa, we don't have that credit scoring system in place, and that has in many ways affected our economies, affected even the borrowers and even the lenders, because we don't have a good credit scoring system. In my work, I'm presenting a new approach to address this problem. So let's get to the talk. Okay. So microfinancer institutions operate in data sparse and volatile environments. This is very, very true. That in Africa, unfortunately, many times when we see people coming to get loans from banks, they don't get the loans simply because many times the data and the people themselves, they behave in a very, very erratic manner. And so our markets are quite volatile. Because of this, it leads to some challenges. First is that we have severe imbalances in terms of defaults, and we have limited borrower history, credit histories. Like you said, for instance, you want to ask that your friend, okay, who have you borrowed money from before that you return back the money? And the friend is like, okay, I cannot remember, or I don't have anybody I can tell you. That data that is not available is a key challenge with microfinancial institutions, because without them having that information, it will be very, very difficult for them to trust that person to give them their money. Another is regulatory need for transparency and explainability. That word seemed a bit longer. All right. So many times we don't find people. We see that these financial institutions that want to give out loans, they don't explain the models to the regulatory bodies that are coming to seek to know what is it that what matrices they are using to give loans even to their borrowers. All right, so this has resulted to high default risk and inefficient capital allocation. There are times that even banks, for their total budget for a year, they have said, okay, we want to make certain percentage of interest, from this money that we have, but they don't even engage in that. Why? Because they are scared to give out loans to people that actually need that money. Let's take, for instance, a small-scale farmer who needs some loans to get like fertilizers in a rural community in Africa. Just because he does not have access to that loan or have access to that money to get those fertilizers, he will not be able to carry out his projects. You could use that instance for other cases or other businesses. Now, what we attempt to do in our work is to work on an African-aware context in such a way that we want to look at what are the features that we use every single day across Africa that we could use to build a machine learning model that can be able to predict if a person is a risky borrower or a safe borrower. All right, so first off, we worked on a representative data sets using West Africa. Actually, I'm from Western Africa. To be able to come up with loan records for some, clients. Now, we used the 400 holdout test set, and there was strong class imbalance in terms of defaults and non-defaulters. And simply for those who don't know, to default means they borrow you money and you don't pay back. All right, so the feature groups we we classify our features into 3 in terms of the financial ratios. This was done through feature engineering, repayment behavior of the client, and also the demographic indicators. Now, we built a model pipeline that we could use to be able to do this modeling by replacing the missing value imputations. We did some feature engineering and scaling there. We did class imbalance using smooth and feature selection using the ANOVA F test. We did model training and comparison and cost-sensitive threshold optimization. Now, in all of these things that we did, we looked at, for instance, let me go back to the previous slide, sorry. For the financial ratios, for instance, we checked the debt to income ratio. So we tried to see, okay, how much does this person earn? Of course, in our representative data set, one of the features we looked at was the current income or the income of the clients that is asking for the loan. So that's an example of those. We used about 15 of them, 15 features altogether. The repayment behavior, how many defaults has the person had in the past? For some, 3, 4, 5, 6. Some of these data sets in real life, right? Some of these features we are looking at in real life, we cannot lay hands on them yet. So this is more like a proof of concept and encouraging African microfinancial institutions to start to participate in seeing how we can, bring some of these features on board. After running our model, we discovered that the performance was done on the held-out test set. Of all the models that we considered, we discovered that logistic regression performed fairly better than every other ones that we considered, including ensembles. Now, logistic regression performed significantly, and it has performed even more complex models in our system, like the SVM. The economic impact of this project is that model decisions optimize for cost, not just accuracy. What I want to add to this is at some point when we were trying to look at, say, for instance, if the person pays their utility bills. How many of you pays your utility bills here? Who can bear you witness? All right, so if you pay your utility bills, it was part of the features that were also used for this entire process. Now, the expected loss framework was applied, and the optimal decision threshold that was held for this was 0.4, meaning that if a borrower is borrowing, let's say, if the default for this person is 0.4, it means that the person is actually a risky client. So we discovered also that this led to a 35% reduction in expected portfolio loss. So this is more like an information for the microfinancial institution because it helps them to know that, okay, peradventure, if this system was not adopted, they were going to have this kind of loss. And of course, when we apply this system in terms of this model, we discovered that there will be a 35% reduction in the overall loss in that portfolio. Now, MFIs, direct translation to capital preservation, even for MFIs. So, as I said earlier, if a bank has a particular amount that they want to give out, a microfinancial institution, whatever, they want to give a loan out, they'll be much more certain that this loan they are giving, the capital that has been allocated to them for that purpose, will come out at its best because they are giving it to clients who value it. Now, for interpretability and transparency, we made sure that we did not deal with a black box. And as I said earlier, the third key challenge that many microfinancial institutions have is that they many times don't... Oh, sorry. I should still be here. Sorry. I wanted to just move my legs a bit. So, as I said earlier, the major problem that microfinancial institutions they realize is because many times these regulatory bodies want to see their processes. They want to know how did they achieve what they achieve, how did they get to that final point. But it's not, many times they cannot because, of course, it's a black box process. Now, our model can be able to do sharp values used for global interpretation, and individual loan level explanations are also available. With Sharp, we are able to check the explanability as to how each feature contributed to the final result to classify a borrower as either a risky borrower or a safe borrower. Now, the support that this gives, it gives regulatory audits in terms of interpretability and transparency. Number two, it gives trust with loan officers. And finally, ethical development. For our deployment, we have some next phases that we are looking at. The first thing we'll seek to do is to partner with MFIs to our piloting stage, which we are already working on. For instance, we had a discussion with Momo Benin Republic on how we can be able to bring this project to fruition. In fact, it is one of the major challenges that they faced, particularly in Benin, in terms of borrowing, giving loans to borrowers. I think there was an instance of saying that someone who is failing to pay his electricity bills, how will he be able to pay back loans? So we want to, number two, do live A and B testing on this process, and then finally, we would like to do model refinement and also to scale. Lastly, my conclusion, and then this is my ask. This is our ask. Sorry, I didn't give credit to Jason Quist, who we worked together on this project in Ghana. Simple interpretable models can outperform. Now, the first thing I want you to take as a key takeaway from this is there are some instances where you want to work on some machine learning models that you will discover that even simple models can be able to outperform complex models, although there are some factors to consider. It depends on your data set and what you have in hand. The second thing is cost-aware machine learning drives real financial impact. Cost-aware machine learning drives real financial impact. For us to impact our continent and our economies, we have to see that we have a clear opportunity for people to be able to borrow without any hesitations or any kind of obstacles. The last is African context modeling requires tailored design. And I am saying this here because there are many times we want to bring models or bring practices from, the West, which is profitable, but sometimes it does not meet our context. This is the reason why we built an African-aware data set. It's in process, actually. Our seek is that we want to pilot this project with partners, with collaborators, and communities that are interested in this subject. We seek to see how we can be able to get more people who can be able to participate in this project by collaborating through data sets and, of course, as I said earlier, through suggestions. Thank you very much for listening.
Thank you very much, Chris, for this talk. It was really interesting. And wish you all the success for your future work. So we have time for a small Q&A. We have some questions. I have one question. I'm sure I can start, and then we can have some questions from the audience.
Okay.
So I was wondering why, logistic regression are overperforming complex knowledge, given that this kind of task includes a lot of features, and then I was wondering why simple model was better.
Okay, thank you very much for that question. That's an important question. As I said earlier, there are some factors to consider. First off, I said that the data set we worked on, depending on the data set you are working on, there are some data sets that you work on that are limited. When you have limited data points, of course, you see that your model will not perform as well as when you are dealing with a more complex model requires much more data set to work with. I hope I answered your question. Any other question? Okay, the moderator is here. Yeah. Yes, you can.
All right. So I am actually quite interested and I can offer a platform for you to pilot.
Okay.
I am co-director of Pumpkin Finance, which is a loan business in South Africa.
All right.
We are doing unsecured lending of short-term loans. So my question is around, so we're working on trying something on behavioral analysis.
Okay.
To basically granting credit.
Okay.
Trying to infuse that with your credit scoring. So would this be like a certain element to that? Are you looking to explore maybe those parts? And yeah, I'm happy to also have an extended conversation about this.
Okay, thank you very much. That's a compliment. Of course, as I said earlier, we're open for collaboration, so of course, we're going to have a discussion immediately after this session. It is very, very imperative that we share minds together because I strongly do believe from our work that one of the things that Africa needs impact the most in is in financial empowerment. And of course, if you want to empower people, you most definitely will need to give them loans. But as I said, many banks are afraid to give loans. So of course, we are open to partner with you. My moderator, who is answering this?
Morning.
Thank
I
you.
love what you're doing. It's amazing. A question. So I do understand why this is needed, and especially here in South Africa, I think it'll do really well. The question I have is, have you guys rolled it out? Do you have any users, or is this still in a concept phase?
Yes, thank you. As I said earlier in the second to the last slide, we are still waiting for our pilot phase. So that's the next thing we are looking at already.
Okay, so you need the investment in order to get the data set, or would you want to pilot the project in communities just to maybe get the data sets and then try and go quickly?
Yeah, of course, we are working on getting the data sets now, of course, to get some form of approval because, of course, when you are dealing with finance, you are dealing with privacy also. People's personal data, they may not be free to give you their data. And, of course, any financial, for instance, if you want to get the income of an individual, it's a private information. If you want to get their age, you know, it's a private information. So if you want to get those details, you need some form of authorization, you understand, to be able to get search. So we are still working on that currently, and as I said earlier, we're open for partnerships. Yeah.
Thank you very much for this presentation.
Yeah.
I want to go back on the test environments. You say work in some extreme case. So in practice, would it be enough to proceed with the small technique
Please, I didn't get your question. Could you come again?
for the class environments?
Class imbalance, yeah?
Was it enough to use small?
Yes, for our use case, especially for our data set.
To my knowledge,
Yeah?
in extreme cases, we need to combine maybe with other techniques.
Other techniques, yes. Yes, that's what I said. This is a proof of concept, and for what we've worked on currently, and the data set available to us, we discovered that Smooth outperformed other method, class imbalancing, balancing methods, yeah. You get what I said?
To what extent it was imbalanced with the data set?
In terms of,
Average, yeah.
sorry?
In terms of average.
We looked at, if I still remember clearly, I think it was 60-40. Yeah, that was the imbalance, yes. So it was not so much, it was not balanced. Yeah, it was 60-40, and it's somewhat affected our work. So we're looking for a way to be able to sort out that problem, and that was the reason why we used Smooth. Although we tried other approaches, but we discovered that Smooth was performed better than other methods for balancing our data.
I don't know if I have this information, but is it the binary classification, not multi-class?
Binary, yeah. Default and non-default, 0 and 1, yeah. Okay.
We still have questions? Good. So thank you very much, Praise.
Okay, thank you so much, everyone, for your time.
So please now welcome Mr. Montasser Ben Masoud, so professor at Tunisia Business School, and also leading of AI for software engineering, and also highly dedicated to promote machine learning and AI in the African continent. So round of applause, please.
You hear me? Good. So, hi everyone. Glad to be here with you in South Africa. I'm Montasser Ben Masoud, tenure track assistant professor from Tunis Business School. I'm coming from the extreme end of the Africa, so we could say this talk is a kind of full north to south journey. So here is a glimpse of Tunisia from where I come, and it's charming Mediterranean style. Just a little twist, a historical twist. The ancient name of that region is Africa, and somehow it ended up naming the entire continent. So somewhat, maybe Africa owes us a little bit of gratitude. So today, I'm really pleased to present two papers published in highly venues journals. The first one is the short version. It's published in IT Professional magazine, Q2 journal. And the second one, it's the full version. We extended it to submit it, and it has been accepted in the top tier software engineering and AI journal, Journal of System and Software. So the spirit of the work, it's a collaboration between the research, between academia and the industry. Here we collaborated with Vermeg, a company specialized in fintech, in finance software dedicated to insurance and banking. Before I dive in more in techniques, I want to acknowledge my team. Here in my left, Mohamed Tounsi, lead product and manager at Vermeg. Here, Mohamed M. Kaur, associate professor at Michigan University in US. And on my right, my two students, they are bachelor, they are senior grade level students. And you heard it right, these senior students got published and have Q1 and Q2 journal papers. This is incredible, but we made the surprise in terms of research. The entire work, it was a final project. It took us six months to prepare the prototype, to deploy it, and to test and get the feedback from the Vermeg company. Vermeg, let's say it's more than 300 developers specialized in fintech. It's great. It's really big company. So the story starts. The journey starts with the grant. I got the Tunisian Young Researcher Grant in 2022. At that time, I looked to make a bridge between academia and industry, and I found Vermeg as a good partner to do my research, especially in maintenance, software maintenance, and backtracking systems. In 2024, we fixed the topic of the projects and we got a lot of visits in Vermeg, discussion with their managers and lead product. And in 2025, in let's say 6 months, we got the papers accepted. We start with a short paper, and we then extend to the long one. And now we are in Africa. Maybe we are looking for other partnership, maybe other domains, because we have the prototypes which are already deployed, and we have a lot of feedback from the users. The journey, okay, it's fully of many encounters from academia, from industry, and all people. These people, they have believed, you see here, in what we have launched, the EYES initiative. EYES, it's AI for software engineering, EYES initiative. So for now, we have two partners, Vermeg from Netherlands and Regnology from Germany. Both they have representations in Tunis. So technically speaking now, the context of our work, it's the defect classification. Okay, the defect, it starts from an error, a human error on the code, and this error on the artifact of the software, it can cause a full failure of the system. So our motivation here is to detect these failures and assign them to the appropriate developers, the best developers who have the best skills and expertise to fix them. So finally, the prototype we have developed here, it's an assignment system. So now I will jump maybe on some of the problems evoked by the previous presenters, maybe in terms of data, because when we touch concretely the data inside Vermeer, we found them reporting the bugs in terms of just title and description. And this is our contribution. Because apart the prototype, apart the solution we made some recommendation, we have some guidelines for Vermeer, for the leaders, the lead product, the managers, how to deal and how especially to report in the best appropriate manner these bugs. So among our guidelines, we recommended that the developers, in place of the title description, they have to report the environment where the bug have been the priority. Also, the actual results we got with that bug, with that defects. We go further with steps to reproduce, S2P, and the expected results. Because we realized that the developers inside Vermeer, they don't took a lot of time to, okay, they took the time for fixing the bug, but not to report what they have made concretely inside the software. So among the guidelines is to switch to maybe this way of maybe describing in the best way the bug. Why? Because we are targeting not just this prototype for assignment, we are targeting a toolbox of maybe other solutions, like the duplicate bug classification and detection, like maybe using LLM inside Vermeer, because LLM, they need a lot of data. And the data, as my colleague said, they need to be really well structured inside the system of the company, the data set. So this is the first recommendations we've made inside the Vermeer. So here, the bug, concretely speaking, when we have to assign it, there is no one single developer to fix it, because the bug can touch a lot of artifacts in the system. So in this context, one bug maybe we need to, okay, thank you. So one bug in this context can need more than one single developer to fix it. So using this idea, our objective was especially to save the time, to guarantee the welfare of the developers, and maybe to avoid that the bug can multiple duplicates and be fixed multiple times. So in the literature, we found different types of classification, starting from the binary classification. We got the defect, and we had to classify it as defect or not, binary. There is another extension, multi-class classification. With one defect, we can have multiple classes, but we choose one single one. So for this context, we are working on the multi-label classification. This means what? That one defect can have multiple classes. And we added to the multi-label classification a hierarchy. And this is what took us a lot of time,
the representation of the whole system inside Vermeer in terms of taxonomy. The taxonomy of the expertise of all the developers, these 300 developers inside Vermeer. We took a lot of time. We applied the bird topic, and we respect some guidelines, respect of the anomalies, and we validate with the managers. In the literature, there is many competitors, but all of them, they deal with the multi-class. The direct competing solution here, it was realized in 2017 by IBM research team. And at that time, IBM, they proposed a hierarchical, it's the same, hierarchical multi-label approach, but without applying the deep learning. In our case, we applied the deep learning, and we evaluated the model with new metrics. We call them hierarchical metrics. We go beyond the traditional metrics to propose our own metrics, which are like age precision, age accuracy, age. This is what goes and what adapts more to this context. So, this is the general overview of the approach. We start from a defect report. Using our taxonomy, as I said, we have designed the taxonomy. We got in total 51 classes. So this is the hard part of the project, because we have the taxonomy design, and we have the labeling of the defects according to these whole 55 classes. So we finished with a highly imbalanced data set. To proceed, here we used Llama 3.1, 8 billion parameters to generate in a few shots learning a new balanced data set. And we finished from 2K defects data set to 20K defects. It was enough maybe to proceed now with the pre-processing, the tokenization, the cleaning, the removing of all the bias. And by then, this is our approach. We start from a flat forward neural network, and we add a new layer. This layer, the spirit of this layer, is to respect the taxonomy, because it's not the usual way we proceed with deep learning, because deep learning is usually flat. And here, we have to proceed using the hierarchy. So this is the main contribution of the work. It's this hierarchical layer. And by then, we got the result in a multi-label manner. This is a sketch from our hierarchy. We have 3 levels and 51 classes. So for the baseline now, to test our approach, we proceed with the same. Up again. Sorry. We proceed with SVM as a traditional machine learning. Up. We proceed also with the traditional neural network, the flat forward neural network, and 3 transformer-based models, the most known one, BERT, Roberta, and T5. This is the new metrics we've applied, the age precision, recall, and age F1, which respect the hierarchy. This is the hyperparameter settings we've used for the neural networks. And we've tried to answer 3 research questions in that work, because we have to make the difference with the guys from IBM. First of all, how does data augmentation impact the performance of our approach in comparison with flat structured models? How does the model performance change when considering hierarchical? This is the keyword here. Hierarchical, distance-based. And RQ3, we need the evaluation coming from the developers in Vermeer. This is the results we got. Ultimately, we are the best compared to the 5 models. In terms of micro average, macro average, same.
This is for the basic evaluation metrics. And here again, for the hierarchical metrics, again, same, we are also best. For the survey and the feedback, we asked 10 developers from Vermec to test and evaluate the models. We go from junior to senior. Here is their profiles. And overall, there are a lot of satisfaction. Why? Because, look guys, here, even when we made some errors in the classification, look here, here is the correct label. For example, for this defect, we got this class, this result. It's reliability. So it's not a full error, because we got the top of the hierarchy. We are on the reliability. So it's like a partial error, not a full error. And by then, maybe we made the error on the failure process instead of error handling and the triggered error. So somehow there is another spirit to handle the errors inside that prototype, because we need to make always the difference to the hierarchy. So overall, the results were really satisfying. So now, apart the technical side, some of the outcomes of this prototype was the EYES initiative we have launched. EYES initiative, we got a grant from IEEE to proceed with a summer school in the region of Carthage in Tunis. And we succeeded to create a community of, let's say, PhD students, masters, postdocs, all of them reunited for the EYES objective. So here is some video for the taken from the school. And for this edition of the summer school, Vermec was our gold sponsor. And the spirit of the school is eventually to talk about the problems of industry that interest especially the academia. After EYES 2025, we go further and we expand beyond the borders, because we considered another winter school, but at a level of African level, and we succeeded to invite more than 20 experts from North America, from Japan, from Europe, just to create and maybe to inspire our students in Tunisia. We finished, guys, with 150 attendees in person and 340 online. Postdoc 4, PhD 21, and we got 4 industry partners for this edition. And here is some feedback coming from LinkedIn. Ahmed Hassan, one of the leader in software engineering, here is his post on LinkedIn, 2 minutes. The future of AI software engineering is bright. It counts a lot for us, such recognition. Same, full professor, Bruce Maxim from Michigan University, honored to be part of this great event. A lot of acknowledgement coming from the students, postdoc, from PhDs. So here now, according to this experience, now we are extending the work to maybe Regnology, further than Vermec to Regnology partnership, because Regnology, they are German guys, and they are applying, especially not for the code, they are applying the machine learning for the regulations. So some charts. This will shock you a little bit, guys. This is Africa in research. We are contributing with 0.06 from the best papers and inside conferences, the high venue conference, inside the journals, our contribution, this is 0.06. So there is a huge gap between North America, between Europe, and between Africa. This is not because we're not enough smart, we're not enough. Because our experts, they are on the other side. They're not in Africa. So this is the spirit of ICE, to attract these people to their root. And maybe one of the objectives of ICE, now we are targeting some proposals. This is the top high venue conferences in the world. FSC, ASC, ICSI, ICSME, and SANER. Now we are working. Instead of the grant we got from IEEE and ACM, one slide. Now we are working on proposals to attract these conferences, top-tier conferences in Tunisia. This is the ultimate step we are targeting now. Thank you very much. Oh.
Well, big round of applause for Montassar, please.
We only have time for only one question. Does anyone have any question? If not, then I'll ask the question. I have one question for you, Montassar. I want to know if the model that you were talking about was already deployed at Vermeer. Are they using it? And what do people think about the efficiency? And does it fix problems of bugs inside the company? Thank you.
For this version of the prototype, we are not fixing the bug. We are just assigning the bug. So it's a kind of decision support system. We are targeting the appropriate developers maybe to fix it. And here we took a lot of features, maybe the welfare of the developers, because one developer can't fix more than 1 or 2 bugs by day. So we took, for now it's a classification problem, but we are targeting some optimization adaptation of this solution, yeah.
Okay, thank you. A big round of applause for Montassar, please. Guys, we have a keynote talk in this room. So we have the president of Google in South Africa. So feel free to go over there and enjoy the talk. Thank you, guys.
For those who don't know what an HPC is, HPC stands for High Performance Computing. It's a type of data center where you have storage devices, you have networking, and you have computing nodes, such that this infrastructure, it leverages these parallel resources to solve complex problems. Examples are climate modeling, examples are deep mathematical, physical related problems. And thanks to this huge infrastructure that we have, it parallel infrastructure, we can have now data of terabytes, petabytes, and zettabytes. And this results in reducing the computation time to hours or days instead of having on weeks or months. So how this system works is that on the right side, you have the infrastructure. This is, let's consider Topcal. There is a cluster manager. Usually it's Slurm based, which manages the jobs, and its responsibility is to assign jobs to resources. When I say resources, computing nodes. So what happens is that you, on the left, as a user, you submit a job, and then that's it. It goes into the system. The cluster manager finds the best mapping. It does the calculations. As I said, sometimes it takes weeks, sometimes it takes hours. Once it is done, you get back the results and you analyze it. Just to make a comparison between cloud and HPC, HPC is not cloud. These are two different, let's say, models. Let me start with the clouds and then we go to the HPC. So the examples of the cloud, as you know it, we have AWS, Amazon Web Services. We have Google Clouds, providing like Google Drive, Google Collabs, all these services, Microsoft Azure, and Alibaba Cloud, and here at Ben Guerir we have Atlas Cloud Services. So the cloud infrastructure is, at the end of the day, the hardware is the same as the supercomputer. What is changing is that it is based on virtualization. Everything is virtual machines. So you, as a customer, you go and get a virtual machine, and the virtual machine is a virtual representation of a physical machine. So for this system to work perfectly well, you have to have a strong internet connectivity, because there's always an interaction between the front end, which is the client, and the back end, which is the cloud infrastructure. HPC, with respect to HPC, this is high performance computing. As you can see it, there is no virtual machine. We discuss about computing nodes, and there is the cluster manager, and we have computations are taking place. So the first supercomputer was created in 1964. This was 6600, and it was able to do 3 million calculations per second. Then, for a long period of time, Frontier became world's most powerful supercomputer, and since 2024, we have the most powerful supercomputer again, which is El Capitan in the US, having 1,742 petaflops per second. Petaflops. The performance of this high-performance computing, the metric is with flops, which is floating point operations per second. How fast you can do, how many operations you can do, floating point operations you can do per second. Topcal, which is a supercomputer, which was built in 2020, it has a performance of 3.16 petaflops. More on this. What is Topcal? It's a supercomputer which was acquired by UM6P, and this is managed by College of Computing at UM6P. First installation was 2020. It became active during the pandemic times, February 2021. We had our initial upgrade of NVIDIA GPUs in December 2021, and recently, when I say recently, it was six months ago, we did another upgrade of adding new H100 NVIDIA GPUs. In a nutshell, from the resources, we have 71,000 CPU cores, a huge number of CPU cores. We have 20 A100 GPUs and 12 H100 GPUs. Most of our servers, they have a memory of 200 gigabytes, but we have limited number of servers. If your simulation requires a huge amount of memory, we call it high mem nodes. Each node goes to 1.5 terabyte of RAM. From the storage point of view, we have a last parallel system with an overall capacity of 8 petabytes. What is unique in Topkal is that we have on the rooftop of the data center 1 megawatt peak of solar energy capacity. So this means that on a sunny day, not today, it's pretty cloudy and rainy Spain, but on a sunny day, it generates 100% clean electricity to Topkal, which is unique worldwide, not only in Africa, not only in Morocco, but worldwide with respect to the HPCs. From the ranking point of view, Topkal is #1 in Africa, the most powerful supercomputer in Africa. And in 2020, once we built it, we were top 100. And now, based on the recent rankings, which was released 2 months ago, November 2025, we are ranked at 383 with a performance of 3.16 petaflops. And with respect to the green 500, it shows you how efficient the HPC is. We are ranked at top 200 at precisely 183 with a performance of 4.18 gigaflops per watt. Some statistics, as you can see it, here you see the active users and submitted jobs. But just for you, a user becomes active within a month if he or she submits at least one job. Okay, as you can see, that's from 2023 to 2025. There's a gradual increase where in 2025 we achieved almost double what we achieved in 2024 and almost triple what we achieved in 2023. From the CPU and GPU utilization point of view, as you can see again, so the blue bars are the CPU and the green bars are the GPUs. You can see a gradual increase in the CPU utilization of the whole HPC. 2023 we were 8%, 2024 again this is yearly, okay, to 21%, and now we are 32%. With respect to GPU, we have always high utilization of GPUs of 70, 75 until 82. We are very proud that 34% of our users are female users and the rest are the males. And from geographical distribution, 83% are Moroccan researchers, but the rest, we have 7% international collaborations, especially with MIT, CERN, EPFL, and also we have African, with our African partners, we also have access, we give access to African partners, which they represent 11%. Just for you to get an understanding from the UM6P point of view, how the CPU and GPU clusters are distributed among which departments. And these are the numbers between 2024 and 2025. As you can see that Colcom is the College of Computing, the department that I'm professor in it. So you can see that there are calculations happening. Second most for 2025 is the material science, LIMSET departments. And then we have the physics. This is the applied physics department. Then we have the CERN. Then we have the OCP group, and we have African business school, and they have their own shares with respect to CPU. 2024 and 2025 are very similar numbers. With respect to GPU, same. College of Computing is the most user of the GPUs, let's say GPU burners. Then comes the AI movement in Rabat, which is a let's say institution within UM6P, and then it is divided into some startups like Cleveretics and for example Faculty of Medical Sciences. From the AI packages, we have as our users, they do some research and they fine-tune some AI models. So we have all the packages. Some of them are paid, some of them are open source. And with respect to the simulation packages, we have all the portfolio of the simulation packages like ANSYS, ParaView, MATLAB, Quantum Espresso. Again, some of them are open source, some of them are licensed. Some exemplary projects where Topkal resources were used to have this nice publications. One was using Topkal resources to analyze climate modeling and weather forecasting. Other examples are advancing digital pathology through the African lands, crowdsourcing, and another project is that resources were used to do simulation to understand the turbulence on an aircraft. Some success stories, we were able to, thanks to the GPU acceleration, to gain 30% when we're doing single cell synchronous modeling run on A100 GPUs. With respect to high memory, because of the availability of high mem servers, we were able to run UNet models which require more than 300 gigabytes of memory, of RAM. And with respect to the availability of parallel CPUs, we were able to compute plasma discharge simulations, which ordinarily takes 1 month. So because of the parallel execution, we were able to do it in 5 hours. And as you can see that it was executed on 2000 CPU cores. Access and utilization, to have an access, we have the on-demand portal. It's a very user-friendly, or you can use it the traditional terminal SSH way. In case of support and assistance, there's a team which is always available. Our SLA is 24 hours to reply to you in case of any issues or any supports required. I think that's all from my side. I hope that I was able to give you a quick overview of the most powerful HPC in Africa. And we're always looking for collaborations. And if you have brilliant ideas, please, please consider collaborating with Tupcal to run your research on this infrastructure.
Thank you.
That's all from my side.
Thank you so much, Robert, for your presentation. It was really interesting. Myself, I'm Moroccan, so this is a topic that is really important for me. So we are having some questions now. Does anyone have a question? Yes.
Just to make sure, can you hear us, Robert?
I can hear you. I can hear you. If I don't, then I can ask Rita. So let me summarize it if I understood correctly. So the first question is that if we do comparison between the power and energy comparison, is this correct? If I understood correctly?
No, the cost. So what would be the cost if you did everything in the cloud? Like if you had to pay for these compute services in the cloud and also with data storage and so on, versus what it has costed you so far by doing on-premise. Do you see what I mean?
I have really difficulties to understand. So the cost if we go to the cloud. Yes, it's better because I have difficulties to understand. It's far away.
Yeah. So the question was regarding the cost. Are you collaborating with NVIDIA to get these chips, or are you paying it yourself? How are you managing the cost for the chips?
Good. So in terms of the costs, you know that this is a private university. It's a private university. This means that we are not getting money from the government. So no investments currently from the government. So what is coming? The money is purely coming from the OCP group, and the investments what the OCP group decides. This is where, together with us, we invest money direct. So sure, we have huge collaboration with Dell Morocco and Dell Europe, and Dell makes we also have a strong collaboration with NVIDIA. So this facilitates in buying resources on, I would not say cheap, but in a reasonable prices. We are constantly we are constantly applying for European funds, American funds, to get, let's say, money to invest on the infrastructure. But these are long-term projects which takes a lot of, let's say, bureaucratic and political decisions.
Yeah. The second part of the question, Robert, was what is the difference in cost if I am someone that wants to develop something? What's the advantage of using TubeCal rather than using AWS or something on the cloud that is already available? The cost gate. Yeah. Again, right? Yeah.
Good, good. So first of all, let me be very clear that whatever you can do on TubeCal, you cannot do it on AWS, because AWS is cloud computing and TubeCal is high performance computing. So if you want to do machine learning trainings, you have to go to the supercomputer, because on cloud computing it's inferencing, it's not training. So these are the two different things. Now, if you can't, let's assume that AWS and us, we can do the same thing. We can train these large language models. From the prices point of view, for researchers at UM6P level, these are really negligible prices. We're talking about 0.05 Moroccan cents, 0.05 euro cents. And this becomes doubled. So it's less than 1 cent, 1 euro cent, when it becomes from the external and there's a collaboration in the industry. So we are much cheaper with respect to our competitors when it comes to the CPU. And from the GPU point of view, I know that these huge data centers, they're providing a GPU hour by 4 euros. Our prices is 1.5 euros. So you can see that we are very competitive. And if these prices are not, let's say, are not encouraging, then I think there are other encouraging, let's say, reasons. First of all, data remains in Africa, so we are not sending it to AWS in the US, wherever the data centers are, and we have a very strict privacy and let's say GDPR rules, which are under the Moroccan government.
Thank you, Robert.
Thank you
Any
so
other
much.
question?
I have a question myself. So I was wondering what if you have already measured or seen any impact that on Morocco, specifically that the TubeCal did already, or that it's foreseen for the next year?
So from the research point of view, TubeCal has been playing a pivotal role for our UM6P researchers, as I presented some of the exemplary projects, but these are not limited to. We have a lot of projects, a lot of professors who are using TubeCal to do, for example, in biological sequential genome research. This is one. There's a huge team using TubeCal. There are teams who are using quantum computing simulations on TubeCal. There are teams who are doing some, for example, fluid dynamic simulations on TubeCal, and these require complex mathematical solving of complex mathematical equations. So these are really running for hours, even for days. And we see the impact. And soon what we are doing currently is now we are compiling all the papers in journals or conferences which has been published in top-ranked journals and conferences where TubeCal was used to get those, let's say, breakthrough, groundbreaking results.
I see. Great. Thank you so much. So I think we're going to end the questions as of we're running out of time. Thank you a lot, Robert, again.
My pleasure. My pleasure, and thank you for the invitation.
Please, a big round of applause for Robert.
Thank you so much. Take care. Greetings from Bangarir to you guys.
Thanks.
Thanks.
Ciao, ciao.
Du coup, là, on doit switch ici, non?
Là,
Il n'y a plus de batterie.
impossible, ça charge pas.
Ça, on enlève. Parce qu'il a un port HDMI.
waiting for others to join.
En fait, lui, c'est pas l'organiser. Il faut que moi, je me connecte.
Trop dur ça. Pas juste le mettre en tant qu'organisateur. Je te connecte.
Il me faut mon ordi.
Il est où?
Il est en haut, je crois. Unless il va join dans 5 minutes.
Ok, bah, tu peux leur dire next speaker.
Ouais. Our next, hello? Our next speaker is going to join in 5 minutes.
All those ones are not working. Even those ones are not working. Yeah.
Hello everyone. So now we're gonna start the subtrack language entity and NLP for African languages. So this presentation examines active learning as a principled framework for building efficient cost-aware NLP systems in low resource settings, with a particular emphasis on African languages. So please welcome with me Bonaventure.
I mean, we are not many, so I'll.
For the broadcast, does it come from here? It's for the broadcasts, that's why.
Okay, okay. Okay, so I was saying that I'm going to be talking with you through the whole concept of active learning, and like how we can use it to build more efficient African language technologies. So I'm not sure how many of you know about active learning. You probably just know much about like how to pre-train a large language model on a vast amount of corpus. I mean, a vast corpora, but is actually active learning is actually an interesting paradigm because it allows you to do what semi-supervised or self-supervised learning methods are doing, but by reducing the amount of like compute, resources, data, and everything that you need. So the basic definition is like you are roughly building a model that learns itself to select the sample that it needs to optimize its own performance. Oh, sorry. So usually the whole active learning loop looks like that, where you first of all have your model that you are training. You start with a like small amount of data, and what happens is like you have an acquisition function that allows you to make the selection in batches. And as you do that, roughly, it is the stage where your model is trying to know or to point finger at samples in the data space that it needs to maximize its own performance. And obviously, like if you are in a labeling setup, then you can use that to actually know which samples to label to allow faster convergence and better optimization. So, I mean, there have been many benefits to this because many papers have shown that you can, like using active learning, you can achieve like high performance with only more or less 20% of like labeled data. But the performance that you achieve is still like highly competitive, as opposed to other approaches that, for instance, needs lots of data, especially now that we're in the era of LLMs and everybody's like trying to run for the scaling laws and like just exploding on compute and everything. So we are going to, I'm going to move next. So I'm going to walk you through a few series of papers that talked about this and like shows how this can be efficient in like practical like uses. So the first one is like active learning for speech recognition. Roughly the idea here is like you need to have a model that allows you to transcribe, right? But the interesting question is like, if we're in the low resource settings, how can we prioritize which samples to like select from? So this paper was published last year at ACL, and the idea was like, how can we build, the problem at hand was like, how can we build African accented English speech recognition systems? Like, I assume like we all speak English, but the way I speak English is not like the way a native speaker will speak English. It's not the same way like South African will speak English. It's not the same way Nigerian will speak English. So the accent is like pretty much important to not butcher like what is being transcribed. So in this paper, I wanted to show that we can use active learning to have more efficient systems, but at a way better efficiency cost. So roughly, wait, I will try to, I will try not to go too deep into techniques, but this is roughly like the different steps that everything goes. And what is interesting here is that we can make, using like acquisition function and like guided by the principle of like the epistemic uncertainty, we can adapt the learning of each asset by our own model. It's still one model for everything, but you know we have different, I'll say, way of like learning representation from each subset of like accent. And obviously, this is like the standard way of doing the active learning loop, and we always want to query from a data set that we call like the pool data set. That is like a technical term, but you can assume that is a pool from where you want to know which samples to label from. And roughly, this is like the whole process, and I'm going to now move to the result. So like the baseline here is like roughly when you take, for instance, wave-to-vec, and you throw 100% of your data set. Like you have a bunch of audios and transcriptions. We have three different approaches. So this is the baseline, like the normal way that people do the like ASR. And when using the active learning approach, we can see that the performance jumps from like 21 order of rate to 15. This is almost like 27% of improvement across like the general domain. And here we have the clinical setting where like you can imagine, for instance, in a setting where like they are talking with patients, like doctors, like having conversation with patients and things like that. And when we combine both domains, we still have a way better performance using like the active learning approach as opposed to when we just feed 100% of the data. So roughly, it showed that we can outperform the baselines in each of those like domains by using 40% less of data, and that implies that you are using like less compute. Now, moving on, what is actually interesting, because the whole idea of active learning is like you need to be, like as you are exploring and exploiting your data space, you need to be able to see that the variance is reducing, because the epistemic uncertainty is basically because your model doesn't know. So it needs to be able to know what it doesn't know, but then as you are progressing through the rounds, it needs to acquire like more knowledge. So what happened is like, if we are now across the clinical domain, what we can start from here.
Just for people online.
Oh, okay. We can start from here. So from the general domain, like you can see that the epistemic, the uncertainty, like the variance of the model, like the quote unquote, the variance of the model with respect to each accent, these are the top, like most uncertain accents across the whole data set. We can see that across the rounds, it decreases. So that means that our model is like getting more and more adapted to grasp better those like different accents. And we have the same thing, same scenario across like the clinical domain, but I mean on the last round, like it got exploded, which is why there's always needs like to have like a threshold to know how many rounds you actually need to run. And we also have the same scenario across like the top, like when we combine both domains. So that is just one example in the speech domain that can show that we can have better AI system by like exploiting the constraints, for instance, that we have to build things that are more contextualized to the African context, and by also saving resources. And I won't make names, but this has already been like used like in real life, like startups and things like that. I'll move now to the next point. That's just the summary because I don't have time. I'll move to the next point. But the next things now, because everybody's talking about LLMs, this is a work that was published actually 3 years ago at AMLD that tries to use the same approach, but for language modeling, multilingual language modeling. So we call the word AfroLM because if you remember in the beginning, there was this part which was important. But because we didn't have, we were pre-training from scratch, and we didn't have like all the, like, I would say our model haven't been seen on like all the different languages. This part was omitted, those two parts were omitted, and the whole thing was done by the model itself. That's why we have the self, because it's like reflecting on itself. So quickly, how it happened is like we have these like data set of like n languages that we split into two data sets. Then we have the normal active learning round, and we have this part where we take the header data set to generate new sentences that ideally for the language follows the same distribution, the token distribution. And we validate them by, for instance, computing the word error rate between the target and between what has been generated. And given the threshold, those new sentences are added to the batch, and then we restart the whole process. Basically, like roughly as I described a little bit earlier. So we have a lot of experiment, for instance, on like many African data sets. And what happened is like, we can see here that our approach obtained the best performance despite being trained only on like a small amount of data sets, as opposed to MBird and XLMR, which were trained on like terabytes of data set and probably for like many months of training. We still have the best performance in average across all the languages. Now, when we move to out of domain, I mean, those are other like benchmark that we evaluated on. When we move to out of domain, what happened is like we can still see that our approach still works better than like other existing approaches. And then, yeah, we still have the same result here. So even in the language modeling setup, where the idea, the common idea now is like just to take a vast amount of data and then just to throw and then like to pre-train the model, we can still like use active learning and have even a better, more efficient and effective way of doing like creating like more Afrocentric LLMs. Now, this has been done, but then another interesting thing like that I tackled recently was the fact that when like across all those works, and generally what happened is like we have, for instance, a data collection stage, and then like we hire annotators, but at the end of the day, we do not really track the progress. What happens is like we take the data set at the end, and we just like fine tune or like pre-train whatsoever on the downstream task. So this task was actually trying to combine active learning with a combinatorial like approach for this situation where like you can imagine you have, let me say 10,000, and you want to create to label a data set. Which sample should you label such that you not only optimize, like you do not overspend over your budget, but you also optimize the performance of your model when you like, for instance, like throw the data at it. So it was recently accepted at EACL this year, and like it's going to be presented, I think is in Morocco. So we called it like active learning for non-uniform cost for African language processing. So the main idea is like we want to create like, to incorporate the constraints. So here the constraints are just like the budget that we make available to take to have the whole model and the data set built. So we want to make sure that we incorporate those costs to optimize resource allocation, but at the same time by maximizing the performance, because that's what we don't want to sacrifice. So we quote unquote combine like an informativeness-based selection method, and we combine also like a combinatorial like optimization technique. So the knapsack problem is actually an NP hard problem. So we try to use this to obtain knapsack bad, which optimally in real life can optimize data labeling by showing which sample or sentence you should label first, so that on your downstream application you have the maximum performance. I'm not sure if I have a lot of time, so I'm gonna skip through this, but it's like basically like the whole math around how we like create the data set, the unlabeled data set that we have, which is supposedly like the set of like samples that you want to label. We have a cost function that allows you, depending on your scenarios, to know which samples to, not to select, but like how to attribute a normal cost for it. And we have a global budget that you should abide by, and then we have like bunch of like batch acquisition functions. Now, what happened is like, since we are now trying to use the knapsack approach, roughly the knapsack is, let me assume that you have like 100,000 and you go to the supermarket, but you have a bag of like, that can maximum contain 1 kilos. So the knapsack is how can you select the items from your supermarket such that you stay within your budget of like 100,000, but by staying also, by abiding by the requirement of your bag, which only can contain like 1 kilo of like product. And so that is roughly we are maximizing, because we still want to make sure that while we are we are staying under the constraint of like the cost, we have the selection of like samples that are informative for the model, for the downstream task. So I think like we have like 2 different methods. I'm going to skip through. And roughly what happened is like we have the performances here. So the baseline is like the normal way people do like the whole process, like using the active learning approach. And we have those 2 techniques as our approach. And what happened is like we can see that we get way better performance. Now we created different scenarios in which it depends how the annotation is done. So for instance, this scenario 2 depends on like the annotator's like reliability. So we assume that if you are asking someone to label a sample, if the person has more experience like in the labeling, then the more experience that person has, the higher it should be paid. And same thing for the level of extremity, for the scenario 3, where it depends on the sample difficulty. Like if the sample that you are labeling is difficult to understand, what happens is like we assume that you should be paying more the person who should focus on it, as opposed to like something that can be quickly and easily understood. Now you probably noticed this level 1, level 2, level 3. I can go back here about how we created those different like functions. 1 second. No, it's not here. So roughly, if I can come back to this space, roughly what happens here is that we have, depending on the scenario, we know how we sample the different costs. But you can imagine a case where there are a few, like if you have a budget of 5,000, a few, let's say 100 or maybe 1,000, take up to 95% of the whole budget. And everything else is like split among what is remaining. So in that scenario, how the model should still be able to allocate where the resources while maximizing the information like that is given to your model. And this is what we have. And what it shows is like as we are moving deeper and deeper and having more extremity, our performance of our method is getting wider and wider across different scenarios, across different language, across different like levels, and still is beating the baseline, which if you can see the progression has been like decreasing. And we wanted to see if there's like quote unquote like I wouldn't say correlation, but if there's like a relationship between the cost extremity and the whole thing. So I will quickly wrap up by, okay, so this is another paper, but I wouldn't have time to present. And the last thing I wanted to quickly talk about was something that I'm currently working on, like just 1 or 2 minutes. The way we currently do evaluation is pretty bad because we just like select a data set and then we have a metric, downstream task metric, and then we perform the evaluation, we take the average. But I think it's pretty wrong because it doesn't really allow us to know the underlying understanding of the model on the task. So what happens is like, we know that evaluation is expensive, not all questions are equally informative, and a standard benchmark treats them as uniform. But then the problem is, how can we make it better? So what I have as an idea is, I'm not sure if you guys are familiar with item response theory, but the whole approach is like, instead of like throwing the data at your model, you want actually to have an estimation of how difficult the sample is and how discriminative the sample is. So then if you have a population of LLMs, for instance, or system that answers the question, what happens is like you can rank them to know which one will be able to answer this question, which one will be able to answer these harder questions. That will allow us to have what I was calling a model skill, right? And roughly, like, we will have an evaluation that is going to separate the model, showing the uncertainty, and that evaluator roughly is going to allow you to really understand if your model knows your task. And if the model really knows your task, so it should be able, for us, as opposed to IRT phenomena like that are normally asking what is the probability of a model answers a given question correctly. What happens here is that we will now be accounting explicitly for like the variations, the model difficulty and the item difficulty. And I'm going to quickly show the result and move. So we now train like the skill as latent variables that can be learned actually, instead of like something that we just rely on from the benchmarks. And we have some like preliminary results. I'm not really yeah. So if we can see here what happens, like we have the models, we have the skill estimates, we have the variance. And one thing that is interesting is like, I think if this works, that will mean that you can be able to estimate how well your model will perform on a data set by knowing the model, the level of the skill level of the model. So instead of like evaluating 100 or a huge amount of data sets, by knowing the skill of your model, for instance, you can infer how well it will do, assuming that your model answers correctly like most questions. And that could be a very good shift like in how we do evaluation and also how fast it happens. Yeah, so I think that is it. And like, sorry, like we had technical issues, but that is what I wanted to share with you roughly today. And I know like AL is not something most people work on. It's mostly used for drug discovery and everything, but I hope I was able to show you quickly, even though I skipped through some slides there. This is one of the ways we can go about to build more efficient like system for low resource settings by taking into consideration constraints from the environment, data, compute, and everything else, and also like from an evaluation perspective. So yeah, thank you.
Thank you, Bonaventure. Does anyone have any question? If not, I have, yeah, there you go.
Thank you, Bonaventure, for your talk. I want to come back on the talk where you speak about the costs, the malware pack. And my question is, how do you construct the cost that you allocate to each data sample?
Good. So that is a good question because in practice we didn't have it. So that's why we like simulated it. So for instance, we have a scenario where we, for instance, simulate like the annotator's reliability. And now using that annotator reliability, we pass it, for instance, to a monotonic like function, like an exponential functions that allows you to have like higher cost for higher reliability and lower cost for lower reliability. Now, that being said, if now you have the cost, the real cost, you can just plug it in and everything else like will just work out, and you should be able to have like a table like this.
Okay. Okay. So that brings me to another point.
Okay.
I mean, I got the opportunity to be exposed a lot to the cost-sensitive learning literature. And recently, people, as we don't have by default the right cost, people start to imposing a kind of uncertainty measure on the cost.
Yes.
To, I mean, improve the reliability of the system. Do you think that we can, I mean, shift a bit what you did here and trying to take also account the uncertainty on the cost, which is construct using the segment?
Yeah, I think what you are talking about might be presented somewhere here.
Okay.
Because if it's about the uncertainty from the model, we are getting that here. That is this metric. So we are like So for instance, here we are using batchboard, which actually tries to maximize the mutual information between your model's parameters and your model's predictions. Now, if you want to use a purely uncertainty based approach, you can still, but then that will mean, for instance, that you might want to minimize, because what your model is most uncertain about is, like, for instance, what should maybe cost more to label, for instance. But at the end, it should be able to be helpful for the learning of the model to improve the performance.
Okay,
so those are like ways like you can play around this.
Okay, great. My latest question about the skill.
Okay.
Uh, do you see the application of the skill, concept that you introduced here in, for example, the medical imaging settings and
Okay. So in the medical setting, let's say, honestly, I don't know. In the medical setting, honestly, I don't know. And this is like still under running, because another things that I'm trying to run is trying to have different other metrics. Like, for instance, if a model does well on a benchmark, for instance, let's say, for instance, a mathematical reasoning task. If it does well, for instance, on GSM 8K, can that skill be transferred to another like mathematical reasoning task? So far, it's been doing well, but not better, like on par with like the baselines. But I'm still running the experiment, and then it should definitely be better. But then, like, it can be very useful for many other contests. Okay.
Yeah. Thanks for your presentation. I wanted to clarify something. So you said that if you have several, let's say LLMs, for instance, you can rank the one that will be the best to answer a given question.
Yes.
So how does it play in your optimization scenario? Yeah.
Good. So what happens is here, is I took the idea of the inspiration from like the item response theory. So what happens here is, like, you can assume that you have, let's say, like, we have this classroom, right? So we have a list of questions, and then we have a list of subjects. So you, me, her, him, everybody answers the question. So now, using that population, we can have an estimation of like how a specific question is difficult and how discriminative a specific question is. So if we have that estimation, we can allow us, like each other, to label, like, for instance, if you're able to answer most easier questions, that means like your skill is pretty much lower than me who answers harder question.
What's your measure of complexity here?
So it is actually, I'm not sure what you mean by measure of complexity.
Yeah, because you mentioned with let's say you have a distribution of questions, right?
Yes.
Okay, and how do you know which one is harder than the other?
Well, that's why you have a population, because if you have 100 people that are answering a specific question, if they all get the same question like right, then you can assume that it's pretty much easy. But then if there's a huge variance in how they respond, then you will assume that the question is like challenging.
Okay, so it comes to how the LLM, like how stable is the answer from the LLM?
Yes, for now, yes.
Okay, thanks.
Bonaventure. So now we will move to a new speaker. Her name is Marie Didier. The subject that she will be talking is cultural heritage and archives. This talk presents a hardware-enabled physics-informed AI approach to multispectral imaging for cultural heritage material identification. Please welcome with me Marie Didier.
So it's okay? Yes, okay. Should I start, or there is one, no? Okay. But everybody else, okay. It's only you, no?
use this kind of hardware that we built to extract meaningful information from material, and this information then produce a lot of data, and we use ML to analyze this data. So first of all, we always talk about like multispectral. So what is multispectral? So as you know, here we have the eyes. The eyes is generating only 3 small channels to look at images around us, so RGB. Then we have standard camera that are a bit better. So then with that, we can have what we call limited visions, but still the broader information. So this camera have more detection and more information than just the eyes. And then the enhanced vision. So as you can see here, we multiply the amount of data we are generating or like catching. And this is what we call multispectral camera. At Matisse, so Matisse is a startup in Switzerland, we developed this illumination-induced multispectral camera that gives us a lot of information. So first of all, there are things to understand what is the innovation a little bit like this. It's first, let's go to traditional and a comparison between traditional and what we develop in Matisse. So the traditional setup, as you can see, for example, here is to look at artifacts in the museum in Berlin from Ramses III. And this equipment it's what's usually done. Okay. So it's okay. This equipment is usually what's done in the multispectral. And it's huge, it's cumbersome, it's really not adequate, but it gives a lot of data information, and most of these data and informations are not enough readable for like archaeologists or art historians. For us, Matisse, you can see we reduce all this equipment with a single camera, and that can be portable and can be extremely hand-free, user-friendly for people who are not engineers nor scientists. And this is a new innovation in that. We bring on-site a technology that gives us the opportunity to record a lot of data directly on site. So that's how it is, very simple. And it is working like this. So one click, a lot of images. And these images are actually what we call multispectral. You can see there are some images that we cannot see with our naked eyes because it's in the UV and in the infrared. And there are some other images we can see with a different flash. So this is very important to understand how we generate data and how we analyze this data. So first of all, what does this multispectral reveal? It is from UV to infrared, as I told you. And then this, in cultural heritage, it can be on painting, it can be on frescoes, it can be on different artifacts, cultural artifacts. For example, we work in the tomb of Ramses III or different artifacts like this. UV reveals what's at the surface, and then the more you go in infrared, the deeper you go inside the material. So here, for example, you can see what's underneath the paint layer surface. And all these bands in the middle, you can see when I show you the videos, it's one click and 17 images. All these 17 images, those bands, there are multiple enhanced vision. We are using this information to detect the material DNA. So how do we do that? From the intensity to material DNA. So first, I told you we have physical material, so pigments, different paintings, different artifacts. We have the data generator, that is our camera that we created, and the analysis, that is AI-driven analysis. I will be a bit, fast on a few things, but it's not very complicated. It's just to understand. So it's important to generate data. Okay, fine, especially for ML and AI. However, generating good data is extremely crucial. And that's why when you're dealing with images and then after material DNA, that is something that is more than just intensity, we need to have intrinsic calibration. So it is very difficult, especially when we talk about a system that is supposed to be 100% used outside on the field, in archaeology sites, in museums, in different environments. And that's why we integrated the intrinsix calibration. So as I told you, we have 1 click and 15 images from IR to UV. And these images, each time, is captured with an LED that is emitting at a specific wavelength. And that we integrated, we have a database of what we call white reference, and we have a cloud-based software. So once these images are taken, they are uploaded on the software online, and there is a process of calibration that is done. So in the end, what you can see as an image from our data generator, the camera, is not just intensity as you see with your phone or something else or something like that. It is what we call reflectance. And one reflectance is one spectra, and it is corresponding to one material DNA. So now you can see there are so many DNAs. Each of the pigments, you know, in life, or anything that is colored, even the dyes, the clothes, anything, has a reflectance spectra that defines their material DNA. So you can see here, for example, it's a pigment checker. Each of those different pigment checker generates his own spectral signature that defines its materiality. And in normal traditional multispectral analysis, as I show you with the big equipment and people who are totally not AI driven, usually they look at those spectra and they have a reference chart and they try to compare this spectra and say, maybe this color in this artifact should be this red. So then they have their database of reflectance spectra and they check and they compare classically the spectra. But you can see the limit, and you can see also why I'm here, because we use machine learning in order to be more robust and to go faster. So how do we do that? So of course, you know the classic scheme that is always like that. So we have our data set of elements, and then we use convolutional neural network, pixel-wise processing, this is important, so that we can have classification and we can give a results on and mapping pixel-wise on which material is where. For example, this painting here, you can see different classification and results with all the legend of the pigments. That is not, okay, I put here something, so for some people who wants to learn, as you know, I am not the machine learning engineer in my company, but this is, of course, if you have more questions after that, we can go over there. But which is quite interesting because we don't use like libraries or specific libraries as a black box, and our machine learning engineers develop something to have a multiple results assessment. And I will go there because we need to have a lot of model improvement, and especially what we call physics-informed modeling in order to integrate into our model some physical aspect of the theory of absorption and reflection of light and material analysis in order to get a good results. I'm going a bit faster on that, but you will see where I go. So you remember before, we had this image of the null of the color pigment checker with the classic spectra that is usually used to recognize material in different paintings or artifacts. And here with our algorithm, so first we take a picture, we run the algorithm, and we get this kind of segmentation. So you can see it's faster, it's more robust, and it's also pixel-wise. In our work, we work closely with people who are restorers, very close to cultural heritage, material. For example, it can be natural pigments, organic dyes, stuff like that. So we built our database of pigments or different material, and we take picture with our camera and we train our algorithm on that in order to give a results. So a use case. Now, because I told you a lot about a little bit of theory before, this is a very typical use case. This is a Japanese print from the 19th century, and this is a visible image. Here you can see different reds and the blue and the yellow. And the restorers in the museum, they wanted to give a diagnosis for restoration on this painting. It's very, very fragile. And we cannot do sampling, so we cannot sample some pigments from this painting. So what they did, they used a camera and we ran the algorithm. And they find out which, of course, color difference corresponds to which pigments. And not only this, you can see here that the result of the classification from our algorithm shows this flower here, different color from the background. Whereas here in the visible, they have the same. So it means that this pigment here is actually different from the one used in the background. And in our eyes, we thought it's the same. But this is extremely valuable information because then the restorers, they know which materials they can use for diagnosis. It helps for authentication, datation, and restoration principle. And when we deal with machine learning results, it is extremely important also to deal about the confidence. Okay, so and that's why also I'm totally open also for your question and remarks on that, because we are trying to express a way that reflects the probability or the confidence of the model for people who are not machine learning experts. So we know, for example, the pixel, how many pixels and with the precision, so you can see it works very well, but we cannot show that to people who are, for example, archaeologists or people working in a museum. This is not an information we can share with people to make the human still in the middle of the processes of diagnosis or interpretation. So what we do, as I showed you before, that's pigment identification and mapping. Yes, we can map, and that's also very important because we can go back into the real data and have the information about, for example, which pigment is where. And you can see it highlights very well. So we have, since also talking a lot about cultural heritage, improvement of the model is extremely crucial. As I told you, we do mock-ups to train our algorithm. And for example, this is a very use case here. This is what we call, we are working on these Egyptian pigments in Luxor, in Egypt. But in order, we cannot bring our algorithm directly on the tomb. Because first we did our training on mockups. This is the ideal case. So we developed different model for that. It worked very well. But then after we went in situ work and the comparison with traditional technology, so that it helped us to improve a little bit of the model because we integrated more complex analysis. For example, the background was not the same background as our training algorithm, so something like that. And then after the on-field work, that was even more chaotic at the beginning, because then you have the external condition, you have some limestone that was not the same limestone as the artifacts in Berlin. So all these things, that's why I'm trying to show how very important it is to do theoretical work and on-site work, theoretical work, on-site work, and also putting all these things together so that we can refine the model and have a better pigment analysis. So that's why in the course of research, let's say, of our startup, we also work a lot with comparison and multimodal analysis so that we can validate each time our results to a certain stage, confidence stage, where we say, okay, now we are 100%, that is okay, and that is working. Now we can publish it and we can make it available commercially for the clients. And this is quite interesting. For example, this is a typical example on how we improve the model with real data. As I told you, on mockup, for example, we have specific spectrum. So one material corresponds to one spectra. And then on stone, on site in Egypt, you can see the spectra from Egyptian blue. It's totally different. So that's why there is a very good importance of good amount and variety of data. And combining them together, then we can simulate reflectance so that from the real data, we understand the theory, we can do simulation, then we refine our AI training, and that gives us a diagnosis for the material DNA. So that's what we call a hybrid data strategy to augment or increase the number of data so that we can have real measurements and spectral simulation. So it is important to understand theoretically what's happening. So that's what we call physics informed, kind of. And then after we use AI to give a diagnosis and run this on a large amount of data. In order to show you how it worked very well, and I told you about the confidence map. Here, this is an artifact in a museum. We map it. You can see here it's very high definition. We can see what is Egyptian, the late white, some other things. And this is a confidence map. Confidence map is still like a big question mark, but the redder the points, the better the confidence. And then how do we interpret the rest? Also, this is a big question mark. So very happy to discuss this later. This is just a very nice example. As you can see, without touching anything, you can map and differentiate and classify those different raw ambers, different pigments, the Egyptian blue, of course, that is very high here, some yellow ochre and red ochre. And as I told you before, here they were like an artificial patina that disrupt a little bit the identification of the background. So we are still working on augmenting our data and understanding of complex pigments, complex background, complex different things, so that we can integrate those data into our analysis. And this is the last model we used, and it worked extremely better, let's say, than the one before. And then now you can see different iron oxide and also like even organic fungi, because at the same time we refine our algorithms, we also increase our database of reference, and all this give us the opportunity to have better results. Yes, as I told you, we have this database of pigments that we train our algorithm with. So it looks like this. So we are really making the link between traditional know-how and craftsmanship and artist pigment identification with deep tech AI model. And that's also what we want to do at Matisse, making the link between the traditional and taking them towards the future. This is a very interesting case because especially, for example, in countries such as Africa or Middle East, where we are, there are a lot of traffic at the border with different artifacts coming from the traditional or cultural countries, part of the country. So here, for example, at the border, you can have a little object that goes to the custom, and then the custom say, okay, check the papers, and if everything goes well, it's fine. They say, okay, you can take this artifact outside. However, there are a lot of forgeries, and people, they don't really know at the custom. So that's why we believe our technology can be extremely good asset in anti-trafficking, anti-looting from those small artifacts at customs. And that's why we are very present in the Middle East. And this is a typical example here. This is a small sculpture from the Han Dynasty. And it was supposed to be like a reel or something like that. And we did our algorithm, as you say, and the picture with the camera, and we ran the results. And you can see here different mapping of different pigment. And we find out, of course, this is an expert who read the results. He found out that actually this reddish that is here in the head of the sculpture, with a very high confidence, by the way, is something that is totally not a signature from the Han Dynasty. It is a contemporary lake, so it means that this is totally fake and has been forged. So see, this kind of result is very valuable against trafficking. The same thing for the other thing. I will go fast because I think I took too much. So this is one more thing, and I think it's the last thing I want to do to show you. This is a Raphael painting. And same thing, we run our algorithm, we find this color is yellow ochre. And we extract the spectra, but from the mock-up in laboratory, the spectra is totally different. So you see those inflection points in real life spectra differs from the mock-up. And this is the influence of binding media and aging factor. So that's why the physics-informed modeling is extremely important for data augmentation and understanding the results. So we do these two things. First, we do the experimental. So we have measured samples and we understand the theory, so we can do data augmentation, because as you can know, it is impossible to train the algorithm on every single pigment or like a complex mixture in the world. So by understanding theoretical model related to mixture of pigments and light matter interaction, we can do data augmentation to improve the quality of our results. And yeah, and this is our team. So yes, this is actually the work of Vincent, that is our machine learning engineer. And yes, that's it. Thank you.
Thank you, Marie-Didier. I have some questions. I want to know, for this camera specifically, is it kind of a service, or is it a both, or you can buy the camera and then you can do things by our...
Yeah. It's a good question. So we do two things. The two things, as you mentioned, service and you buy the camera and you have it's a SaaS. So you buy the software subscription after. Most of the people, they do it themselves, so it's better, But at the beginning, we did some service also. But it's super easy to use, so that's why they just use it themselves.
Yeah, maybe just one more question. I was wondering, the use case of this is, as I've seen in the presentation, are paintings. So I was wondering, like paintings, maybe art, ancient art. I was wondering if there is maybe another use case that I couldn't find another use case that this can be helpful in.
Yes.
I'm wondering if you have any idea.
Yeah, we do. This is one vertical that I presented here to you, the cultural heritage with painting. So it can be painting, sculpture, artifacts on cave, like anything related to cultural heritage. But also we are working very closely with scientific police and forensic, so that you go on crime scenes. It's the same thing. They see things, they cannot touch it, and this kind of things. Each time you have to identify a material that is so precious that you cannot touch it.
Okay, thank you, Marie.
Yeah, you're welcome.
Thank you so much, Marie, and yeah, sorry again for the delay.
It's okay.
Thank you so much for your presentation, and good luck. I see the potential, so congrats to you and all of your team. So let's applaud Marie last time. Thank you so much.
Thank you very much for the opportunity, and yes, sure. Have a good day.
Bye-bye. Thank you so much.
Avec Robert, ça a marché. Il a même pas remarqué.
Il y avait des gens. Quand il y avait le gars qui présentait, il y avait un peu de gens.
En fait, eux, c'est ses potes. Genre, Aurel, c'est son pote. Elle, c'est sa femme.
Dès qu'il a fini, j'ai mis la caméra, je pensais qu'ils allaient rester. Tout le monde est ici. Et là, je me dis...
People leaving. Après, en vrai, il a Il a dit, yeah, we're broadcasting, there's a lot of people. Non, c'est ça. Elle était en mode, yeah, ok, ok. بدي القادرية